As we go on to topic 3 of chapter 9, we're going to be dealing now with logarithmic functions. In the last section, section 9.2, we dealt with exponential functions. And you're going to see a lot of interrelation between these two, logarithmic functions and exponential functions. There is a lot of relationship here. Now, what I did in preparing for this was I looked at the textbook again, and I also looked at the PowerPoint slides. So again, how much you are preparing for this is meant to help give you an outline of what's going on, but your main source of information is your textbook. And you can read it, or again, look at the video that I prepared. I prepared this some time ago, and looking at it, I think I could even do a little better now, but it's what it is. So let's take a look at this then, and I'm going to give you some background to help smooth into section 3 here. And for that, I'm going to use some of the PowerPoint slides. Now, as we look at this one in particular, you might say, oh, we just did this in section 2, where this was f of x is equal to 3 to the x power. Now, you recall the graph of this. And here you're getting to see one of my sketchy graphs as opposed to the really nice ones that I will be showing you later. But this is the graph of this where it's going through 1, and it goes through a 3 up here, and it goes to a 9 up there. And is it a function? Well, it passes the vertical line test, so it is a function. And does it pass the horizontal line test? And the answer is yes. So this is a 1-to-1. So it does have an inverse. And we showed you the inverse the other day as well. Now I'm not sure it's what this is referring to because it was actually in 9.1, I believe we did that. So here we have x equals 3 to the y power. So this is the inverse of this, where we take the x and switch it with the y. And when we made a graph of that, the inverse, again, and I'm not doing this very well here, that's why the real graphs are much better, that it's the reflection of this function is its inverse. And this was the axis of symmetry, y equals x, and this we said was f of x equals 3x, this up here. And this down here we said was its inverse, f inverse equals 3y. Okay, so again, just background to bring you into section 9.3. So, what is this y here? This y is the exponent. Can you all see that? This y is the exponent to which we must raise 3. And what is 3? Our base, to get x. We were doing that in our t-charts, where we would put a value for y, then raise 3 to that exponent, and that would give us x. Now, this can also be written, this, in its inverse form. That's what we have here. F inverse of x is the exponent to which we must raise 3 to get x. That's what this inverse is. Now, later you may be asked to graph this, and again, you already know this. So again, it really ties into what we did in 9.2 and why I spent so much time doing that. And you will need to study it to work on your practice and later your mastery. Now, keeping in mind what we said on the previous page, we're now going to take a look at a new symbol to replace the words, the exponent to which we must raise 3 to get x. And once again, what are they talking about? Well, x equals 3 to the y power. This is our exponent. We're now going to replace the words, the exponent to which we must raise 3, the exponent, this y, that we must raise 3 to get x. And the words we use to replace that is log base 3 of x, which is read in the long form, the logarithm base 3 of x, or, as I read it here, log base 3 of x. And it means the exponent to which we raise 3, the exponent to which we raise 3 to get x. Now, this is super important background that you will need to, look at and study and master. So, thus, if the function of x is equal to 3 to the x, this is what we've been working on the previous slide, then its inverse, f inverse, is equal to the log base 3 of x. Now, here they're giving you an example. Notice that the inverse function, where x is 9, is equal to the log base 3 of 9. And that equals 2. Now, one of the things I'm going to stress throughout this is keeping in touch converting this log expression into its exponential form. So notice what we're saying. We're saying our base, which is 3, right over here, our base 3 is going to be raised to some exponent, and that's going to equal 9. Now, what is the exponent to which 3 must be raised to get the number 9? And the answer is 2. 3 to the second. And that's what they're saying here. But they are saying that the log, then, is the exponent to which base 3 becomes 9. And that exponent is 2. And here they're saying it, because 2 is the exponent to which we raise 3 to get 9. Now, many of you or some of you would have to go over this again, and again, write it out. You are studying to master this. All right, that was background. We're now in our mini lecture again, and we're going to look at graphs of logarithmic functions, which we know is just the inverse of the exponential function. We're going to look at common logarithms, equivalent functions, and then solving certain logarithmic equations. Now, a lot of this will look strange to you, but again, my job is to help you get an understanding of what is here. And that's what we're going to do. All right, what we're going to do is work on these first 3 examples. Now, you would all agree these are in log form. These are logarithmic expressions. But to simplify them, we want a strategy to convert and get an answer. So I'm going to suggest that you set it up in exponential function form, where we know our base is 2, so there's our base. 2 is raised to what exponent to give you 128? We'll get to the answer in a moment. Just setting them up. So our base is 4. To what exponent will give you a 1? Remember, to what exponent is what the log means. We've converted that. And then for this one, our base is 3. To what exponent to give us 1 over 27? Okay. Now here we have 2 to what power gives us 128? And the answer is 2 to the 7th power. If you put that in your calculator, 2 caret 7, it gives you 128. Now, again, a lot of what we talked about in section 2 ties in. Now, 4 to what power is going to equal 1? And you might recall we said this is true for any base to what power equals 1? And the answer is 0. Any base other than 0 to the 0 power is equal to 1. And 3 to what power equals 1 over 27? And we did this one too in our previous lesson. Now it has to be some negative power because it's 3 to what power is 27, but it's the reciprocal of it. So that's going to be negative 3. Okay, now this one is sort of a unique one. When you see, this is not quite in logarithmic form. Here the exponent is the log. And if you looked at our textbook and PowerPoint lecture, we said when you see something like this, all you do is you take this 93, which is part of that log exponent, and that is your answer. And now they're asking us to graph this. Well, remember, what is this? We want to convert this to something like that. And remember, this is the inverse of what we had before. So a little review. The function of this initially may have been y equals 4 to the x power. So the inverse of this, since it's in its log form, the log form is the inverse. We'll be switching the x and the y. We then get x is equal to y to the 4th. And if you recall that, and I can sketch that for you, remember this one looked like so. 1 through 1, and it was up like that. Where this was 1, this was a 4, this was a 16. Now the inverse of that would be, again, coming up this way, going through 1 there, and keeping in mind our axis of symmetry, these were reflections. So the graph of this, and I believe we have that at the end of the booklet, would be this black line. And all you're going to have to do on MathLab and on your test would be to pick out what is the correct graph. As a rule, they don't ask you to graph these. Okay. Now they are asking you to use a graphing calculator to graph this. So you may not have one, but let me work it out for you. Going on to our special calculator here, I've put in, and on a graphing calculator, they just have the key log, which I believe is log base 10. So y equals log of, and then you put in parentheses, x divided by 3 per end parentheses plus 2, and then you ask to graph it, and this is what you get. I'm not sure what this line over here is, but That's what it looks like. Now notice log is your inverse function, and when we were doing the regular exponential functions, our line went up over, oh, that's the wrong one, here it is. Our line went up this way, well, going through 1 though, and now an inverse function tends to go this way. Okay, again, I don't think we will require you to do this because, we don't require you to have a graphing calculator. Going on to example 3, they're asking us to rewrite each as an equivalent exponential equation. Well, this is what we were just doing here a few moments ago. So let's set it up. So as we start to work this, what can you pick out again? Well, we know our base is 6, and we're going to raise it to some exponent to get an answer that is 11. And what did we say the log equals? It equals an exponent. So 6 to the exponent x equals 11. Now, base z to what exponent? Well, -4 equals our answer of 9. Now, our base n to what exponent equals our answer p. So again, we're looking for a protocol, a modus operandi, a strategy to develop answers for these. Now here they want us to write each of them in a logarithmic form. So we're going to put log by each of these. And then convert it to this form. So remember, log is an exponent. Log of what base? Well, there's our base, 4. What's our answer going to be? 64. And our exponent is going, well, let me pause here. I checked myself. No, our base is A. Our answer is 9. And what is the exponent? -2. That's better. Again, our base here is x. Our answer is z. And our exponent is y. Yes, the A and the 9 looks a little bit alike. You have to be careful on that. Okay. So again, these are the answers. They are below. And you want a strategy for rewriting them. And again, putting a log form into exponential form, we're going to see is very, very useful. Okay, going on now to our equations in example 4. We want to solve them. And for these, The method that we're going to use is that if you have, let's say, something like this, in which you have 2 to the x power equals 2 to the 4th power, your bases are the same, then your exponents are the same. So we're saying then that x equals 4, because 2 to the 4th is 16. 2 to the x power, which would be 4, is 16. So this is what we're going to be doing down here. So let me set up number 4. So we're converting this from its logarithmic form into its exponential form, and there it makes a lot more sense. So 4 is our base, our exponent is a negative 2, and our answer is x. Well, what is x here? Well, we just solve it. 4 to the negative 2 is 1 over 4 to the 2nd, which is 1 over 16. All right, let's do this one. Now our base is a to the 2nd power equals 36. Now we want to make 36 into something that has an exponent of 2. So what can we do to 36 to make it into something with an exponent of 2? So we're saying 6 to the 2nd power. So now our exponents are the same, so our bases must equal each other. A equals 6. In letter C, now this is a common log, log of 10, so our base is 10, and we didn't really mention that in our video. We do. When it doesn't have anything by the log for a base, it's the common log, common logarithms in which the base is 10 and they don't write it. So this is 10 to the y, that's our exponent, equals 10,000. Well, what we want to do is convert 10,000 into what power of 10? And it's 1, 2, 3, 4, so it's 10 to the 4th power. So now we have our bases the same, our exponents equal each other. Y equals 4. And for our last one, we have base 7. Our exponent is d. And our answer is 1. Well, if we have a 7 here, and we want our bases to be the same, what power must this base be raised to in order for it to equal 1? And that is 0. So D equals 0. Okay, again, strongly recommend you're reading the textbook or looking at the PowerPoint slides, where a few things will be added to give you background. This is some heavy stuff, and for many of us, it's stuff we haven't covered in a long time. I have, and I'm getting better at it, but again, study, practice, quiz me, and good luck.